What if I tell you artificial intelligence doesn't begin with artificial intelligence? Sounds confusion. Good, because sometimes confusion is the beginning of the better question. So today the whole world is talking about AI. It's something like ChatGPT, generative AI, and machine learning, agentic AI, and humanoid robots, and autonomous factories. Everybody is asking for which AI tool should I learn. But after more than 3 decades of working across the country, manufacturing, technology, and process environment, I want you to ask some different questions. Because AI can learn what must exist. There should be data, okay? But before data, sensing, am I correct? Before sensing, a process. And before that process can be intelligence. So somebody want to observe it, understand it, question it, and redesign it and innovate it. Because wherever the bottleneck in the process can be addressed, it should be observed first, and it need to be understand it, question it, redesign it, and innovate it. So perhaps artificial intelligence does not always begins with the algorithm. Perhaps it begins with the process. Good morning, Vanakkam. I am Thangarajanand, founder of Sai Elite India. Before we beginning this journey, I wanted to express my sincere gratitude. Recently, I have the privilege of sharing this concept in the academic section, which nearly 60 researchers, faculty members, and academic leaders, and to every one of those who participated, I want to say hands of heart, thank you, truly thank you. No simply because you joined the session, but because you actively participated, you listened for a 90-minute session, you listened and you reflected, you responded, and you questioned, and gave this idea something extremely valuable. So there is a intellectual space in that area. My sincere gratitude to the respective principals and head of the departments, senior professors, and faculty members, and researchers and research scholars who made the interaction meaningful, who participated, created one thought in my mind. Why should this conversation remains inside one meeting? Why should it remains within one institution? Why should the relationship between the process innovation and the artificial intelligence not questioned by the researchers and engineers, faculty members, process development leaders? So students and innovators across the India and across the world. So that is why I am here today, and this video is not simply a recording of the session. This is the next level of the conversation. So I already sent this link to the persons who attended the meeting. So you please share this video to your students so that they will easily go into the real life, real world factories. So I have my experience I shared in this video. So let's begin. I request you to look carefully at this title, Achieving the slide 1, Achieving Artificial Intelligence Through the Process Innovation. So I didn't say using the artificial intelligence by for the process innovation. I said achieving artificial intelligence through process innovation. This is a fundamental difference, and that difference is the foundation of the entire masterclass. Let me give you one simple example. Imagine a conventional machine. So it's ordinary industrial motors. It's have a simple no control. First, it performs the mechanical work. Then somebody improves the process. We automate it, and then we add some sensors. So then the connectivity, then we begin collecting the data, then we observe the pattern, and then we predict, then we support the decision. So then the system adapt, then it begins learning from the outcome. So, and one day we look at the system and say, this is intelligent. My question is, when exactly did intelligence begin? Was it when AI models was installed? So not right. Was it when the first sensor was added? Was it when data become available? Or was it predicted becomes possible? Was it when the system adapt? Or was the intelligence progressively emerging through the evolution of the process? It's only by the evolution of the process, am I correct? So that is the research conversation I want to open, not to give you a final answer, but to invite a deeper question. So, and please stay with me until the motor case study later in this video, because I was take one ordinary motor stage by stage, and I ask you to identify the exact moment where the intelligence begin. Okay, I can tell you now, the answer may not be simple as you think. Your motor case study indeed progress from the basic operations, that is through the sensing and IoT monitoring and predictions and AI recommendations and adaptive operations. How did we really reach artificial intelligence? Now let me ask you a question. How did humanity really reach artificial intelligence? Did AI suddenly appears one morning, one scientist opened a laptop and suddenly artificial intelligence? Or of course not. I was a journey, that is in the industrial revolution gives us a machine, then automation gives us the productivity, and digitalizations gives us the data, and our proposition is continuous process innovation helps creating the conditions for increasing the intelligence in the system. Please notice my wording carefully. I am not saying the process innovation alone created the AI. That would be an oversimplification. So computing the matters, mathematics matters, algorithmic matters, electronics matters, and data science and controlled system matters, and finally human intelligence matters. So my question is different. What role continuous process innovation play in creating this condition under which intelligence become possible? Because when a system continuously learns or adapt or predict or decides, we increasingly begin to describe the system as intelligent. So I ask you, did intelligence arrive through our one technology or through the decades of accumulated innovation across the machines? It's only the innovation, am I correct? So the machines, the electronics, the sensors, the controls, the software, the connectivity, the data, and the decision system. Think about it. Are we teaching AI or teaching the engineers who create intelligence? Yes, in the webinar I asked this same question. One of the doctor replied me exactly, the create intelligent is the correct. So now comes the big question. Are we teaching AI or are we teaching engineers how to create the intelligence? Sir, I am telling AI. Some said like that, but wonderfully I asked, what are the learnings? Some say chatbot, some say Python, some say prompt engineering, some say generative AI, excellent. But then I ask, can your system sense? Can it understand the condition? Can it predict? Can it optimize on its own? Can it adapt? Or can it design? Or can it learn? Because the engineering intelligence is much larger than a chatbot. Imagine it's a motor bearing. A mechanical engineer hears some abnormal noise. So an electrical engineer detects some unusual current, or every engineers have some problem facing in the industries. So computer scientists identify a pattern, that is in the prediction dashboard, AI prediction dashboard, and AI researchers predicts failure probably. And in the production line, production engineer changes the process. So now tell me, who creates intelligence? Mechanical, electrical, electronics, communication, or computer science, or AI, or some production people, engineers? Perhaps the complete system did this. And that is why the future engineers must understand the complete intelligence chain. It is sensing. The first start with the sensing, and then understanding, and then predicting, and then optimizing, and adapting, and deciding. Then final stage is the learning. So you exactly slides 3 contents defines this broader chain as the future engineer requirement. So if you are watching this from the mechanical or electrical or electronics or CSC, AI and ML, mechatronics, write your department in this command. So I want to see that. So how interdisciplinary this community really is. Okay. Can AI exist without process innovation? Now I want you to provoke you. Can AI exist without process innovation? Before AI can learn, a process must exist. So without a good process, AI cannot exist. Am I correct? Before the prediction, data must be exist. Before the data, sensing must exist. So before the sensing, engineer intent must exist. So the clear intent is not there. There is no point in sensing the bad process. So let us make this practical. Suppose one students tell me, sir, I want to use AI to predict more failures. Wonderful. My first question is, what is failure? For example, bearing failure, winding insulation failure, shaft misalignment, or thermal overload, or lubrication degradation, or unbalance in the mechanical part, or mechanical looseness. So immediately one thing becomes clear. Before selecting the AI model, we must understand the failure process. Then what will you measure? So whenever there is a chance of failure means you have to measure the environment. So we can measure the temperature, we can measure the current, we can measure the vibrations, and we can measure the RPM, or we can measure the acoustic signals, or you can measure the torque, or you can measure the load of the machine. If I do not understand the process, how will I select the right variables? Because if you reduce the variation in the parts, production parts, or manufactured part, or your outcome, or your service, so understand the process first, then the right variables. So we have to minimize the variations. Then we have to standardize the process. What meaningful data will I collect? If the data has no context, What exactly will the AI learn? So a process, data, intelligence, and AI is the best method. So AI doesn't begin with the algorithm, it begins with understanding the process. So this is exactly the provocation and conclusion in your slide 4 source. So please look into it. The retention, it is and in few minutes it will show you why this question becomes extremely important. When you move from a rupees value from the motor and to a intelligence industrial asset, so my core philosophy is in the slide 5, the AIPI thinking. It is achieving artificial intelligence through process innovation. Is a right thinking model. So now we come to the heart of this entire masterclass. I call this AIPI thinking model, achieving AI through process innovation. So important, it is academic value. I want to state this very carefully. I am presenting AIPI as a conceptual thinking framework. So now as a universally proven law, now as a replacement for the established AI science, but as a framework that can be questioned, because it has to be tested, it has to be redefined, and it has to be challenged and explored through the future research and industrial applications. So that distinction is very important, because a research idea should not fear the questions. A research idea should invite them. So you drop your questions in your chat box, so I can look into it and reply immediately. Okay, observe first. The first step is observe. So every major innovations begins when someone noticed something is going bad or the process needs some improvement. So what everybody else has accepted, there is some small noise in the machine, or there is some delay in the process, or there is some defect in the process, or there is a repetitive movement, the unnecessary movement is there, or there is a rise in the temperature and disturb the quality, or there is a waiting time is there in the process, or there is a customer complaint, or there is a wasting motions in that process. So we have to read this with first sensors. So it's often not electronic. The first sensor is a human attention. This is a highly memorable line. So you have to understand this. The first sensor is the human attention. So once you give the attention, that is a very great sensors. So I over define it, but it is very important. So look into the process. That is the first best sensor. So then second step is to understand the process. So what is actually happening there? What is the physics behind there? What is the process sequence? What are the dependencies? So what is the failure mechanism? What is the human behavior in that process? What is the constraint? Because without understanding, we cannot do the automation. So automation can simply make a bad process without understanding. Then I have a question. Why this method? You have to question each and every steps. Why this sequence? Why this inspection? Why this delay? Or something like that. Why this material is used here? Or why this breakdown is happening? Or why this energy consumption overload is happening? Or why are we doing this? Simply because we have to always done this why. As the why questions, the innovation begins. So when inherited assumptions, because it is visible, then once it is visible, then we need to redesign. So can we remove a step? or combine two operations together, or change the sequence, or reduce the movement, or improve the ergonomics, or eliminating the waiting time, or preventing the defects instead of detecting it later. So this is where the process innovation becomes very real. The next step, fifth step is sense. Then sense what part of the physical reality must become measurable. We need to analyze that. So whether it is temperature or a vibration or a force or a current or a pressure or a position or a vision or any sound, do not add sensor because sensor are fashionable. Add sensing because meaningful process variations deserves visibility. So without adding the sensor also, we can understand the process. When doing the process innovation, no need a high tech process sensors. So when it is in the building process improvement stage, we have to use our sensing organs to understand the situation in the process. Once we understand, once you sense what is the problem, then need to connect, because this is the sixth step. Once you connect, can isolate the information, becomes contextual information, or can machine data connect with the production data, or we can check the quality data connect with the process conditions. You have to connect it to get the answer. Or can maintenance history connect with the failure signature? So you need to go back with the respective records and documents. So once in the beginning of this any process, when it is in the APQP stage, you have to analyze this, and then we need to make a best possible system and process innovation, and then we can automate. So can repeatedly the actions become the systematic. So the repetitive action of improvement become the systematic. And can dangerous tasks become safer, or can variation be reduced? So can consistent improve? But remember, the automation is not intelligence. The automation only flows. Intelligence increasing interpret. So okay, then we go to the next step. It's collecting the data. But please note, not data from the sake of data, not 1 million rows because 1 million sounds impressive, but meaningful data is very important, and is also the conceptual data and reliable data and the relevant data. Once you collect these data, then the next step is to predict what is likely to happen next. Failure, am I correct? Quality drift, or energy spike, or tool wear, or demand changes, or process instability. Then optimize. So this is the 10th step. What is the best action under the real constraint? We need to check the cost, time, energy, and the quality, safety, sustainability, everything. So once you optimize it, then go for learning stage. So can outcome improve our future behavior, or can the system become the better one, or because of the experience? And finally, intelligence is the final step. Now look at the journey in the slide. We didn't start with the AI, am I correct? We start with the observation. We move to the understanding and move to the questioning that, and then redesign, and then sensing, and then connecting, and then automations, and then datas, collecting datas, then prediction, then optimization, then learning, and finally intelligence. So artificial intelligence is not merely a programmed one, so it is a progressively achieved one through continuous process innovation. This sequence and signature propositions come directly from your AI PI framework. So this is a AI intelligence framework. Now you may thinking very good, Thangarajanand, interestingly framework, but does it work for the physical engineering world? I have a question in my session. Can MSME can use this system? Can we apply this thinking too? Like that? I reply to them, yes. I personally train the many companies, corporate companies as well as the MSME companies, tiny sector also, because all the companies have machines. Am I correct? All the companies have motors or actuators. Am I correct? All the machines have some vibrations. All the manufacturing or all having their robotics. All manufacturing unit have failures. So in the next part, I am going to show you why mechanical engineers may become far more important to the AI revolution than many people currently imagine. And then we will tell one ordinary motor and transform it from the hardware into the intelligent asset. That is where the real engineering begins. Let me ask you one question. If artificial intelligence is going to transform the physical world, who understand the physical world? Who understand why a shaft bends, why a bearing fails, why temperature rises, why vibration changes, why material deforms, or why a production line has a loss in the efficiency, why robotic become unstable, why a machine that works perfectly yesterday and suddenly behaves differently today. Is AI alone enough, or does the artificial intelligence needs something deeper? Engineering understanding. And this is why I believe mechanical engineers may become far more important to AI revolutions that many people currently imagine. Look into the slide 6, because why mechanical engineers matters. AI needs the physical world, and so it has to look the variations and look at this statement in the slide 6. AI needs the physical world. So today sometimes I meet mechanical engineering students and they tell me, sir, everything is AI now. Sir, computer science students have more opportunity. Sir, mechanical is becoming old, like that. I want to ask you something who understand machines, or who understand the motion, who understand the force, and who understand the materials, who understand the thermal energy, who understand the vibrations, who understand the wear, who understanding manufacturing, and who understand the failure, who understand the production process. Obviously, mechanical engineers play a major role here. So some electrical and some IT students also, they learning and they understanding it nowadays, because robotics pull them to understand each and every process. So suppose an AI model predict the bearing failure probability is 92%, excellent. But what does the physically it means? There is a bearing animation. there is a inner race defect or outer race defect, or lubrication breakdown, or misalignment, or excessive loads. So there is any contamination in this inside the bearing, or there is some surface fatigue or some resonance. The AI can immediately identify a pattern, but somebody must understand the physical meaning of the pattern. Suppose AI predict thermal deformation in the CNC machine. Who understand the heat transfer, who understand the thermal expansion, who understand the material behavior, and who understand the machine geometry, some cutting conditions, or cutting fluid coolant influences, or so we need to understand each aspects. Suppose an intelligent robot changes its path, who understand kinematic or dynamic, or there is an inertia, or there is a acceleration, or there is a reason for the payload, or there is any structural stiffness is there. Suppose machine vision detects a surface defect only, who understand machining marks, or casting defect, or grinding burns, or tool wear, or there is a material flow there, or a process capability. So AI may provide intelligence, but mechanical engineers gives intelligence a physical purpose. That is the exact key message given in the slide 6. Okay, and in a few minutes I am going to take you one ordinary motor, and not a humanoid robot, but a $1 billion AI system, just one motor. And I will show you how the motor can climb from mechanical hardware towards an intelligent asset. But before that, we need to understand how industry itself learning become intelligence. So let's move to the slide 7, evolution of industrial intelligence. So from the mechanization to cognitive ecosystem, usually when we teach industrial revolution, we start from the timeline, the industry 1, 2, 3, 4, 5, 6. But now I want to see something deeper. Every industrial revolution changes and the capability of the system. For example, industry 1, it is a mechanized industry, and gives us the mechanizations, and it's a steam power engine or mechanical power, and human and animal effort is increasingly supported in this mission. Then the fundamental capabilities was, can we mechanize the physical work? The next stage, industry 2, the scale them, came the electricity, and then the mass production, the assembly line, and standardization, and then it comes the Toyota's type of single piece flow system. And can we produce at a scale, not one products, thousands, millions, like that? At that stage, the automation comes. Then the electronics, PLC comes, the computerized numerical control machine comes, and industrial automation comes. Now the question became, can machine flow program logic? This was a major transition. The machine was no longer only powered, it was increasingly controlled. In industry 4, there is a connection. Then came the industry 4 IoT systems and cyber physical system. It is connecting the machines, data, clouds, and edge smart factories. Now the capabilities changes again. Machine could communicate, and communication creates the visibility. Visibility creates the data, and data creates the opportunity for the prediction. Then comes the Industry 5, the collaboration. Then the conversations expanded. Technology alone is not enough. Productivity alone is not enough. Automation alone is not enough. The Industry 5 embraces ideas such as human-centric, resilience and sustainability, and the human beings comes back to the center, and not as an obstacle to the automation, but as a source of creativity, source for the judgment, ethics, and source for the adaptability, and give them purpose. So it's the collaboration of both machines and robots. It's an emerging industry. Industry 6 directions. Now we move on to the emerging territory. That is the Industry 6 oriented may explore deeper human AI machine symbiosis. That is a deeper human and AI mechanisms, more cognitive system, and greater adaptations, and context awareness and responsibilities is separated for responsible intelligence and also the sustainable intelligence. But I want to be academically careful. These ideas are still evolving, exploratory, and it's still going further to the next step for Industry 7 vision. And when I speak about Industry 7, I speak with even greater caution because I use it as an explanatory foresight. It's a prediction framework, a way to ask. But many top agentic AI and some top future agentic and generative AI, as well as some qualitative and quantum learning, all says that in the future will be a self-evolving one, ecosystem awareness, and purpose-driven one, and collective intelligent one. It is a self-driven, okay, not merely a smart, but perhaps wiser also. So our slide itself explicitly presents that Industry 6 and Industry 7 as an emerging and explanatory future framework. Okay, if you are researchers watching this, and to your view, do you believe Industry 6 should primarily evolve around a deeper anatomy, or human AI symbiosis, or sustainability, or cognitive manufacturing, or something entirely else, something else? Write your perspectives in the comment, because future framework should not be built only by the popular terminology. They should be shaped by the serious research. In the slide 8, the real transformation. Every industrial revolution changed one questions. Now let us stop thinking in terms of version numbers. Let us think in terms of questions, because civilization changes. When question changes, Industry 1 asks how can we mechanize, or Industry 2 asks how can we produce at a scale, and Industry 3 asks how can we automate, and Industry 4 asks how can we connect, and Industry 5 asks how can a human and machine collaborate responsibly, and in Industry 6 thinking may ask how can intelligence become deeply adaptive and symbiosis, and explanatory Industry 7 thinking may ask how can an intelligent ecosystem continuously evolve on its own around for the purpose and for the sustainability and for the human progress. Look at the journey. Mechanize has a scale and automate and connect and collaborate and adapt, and finally it will evolve. Something extraordinary is happening. The industry question is moving from the machine towards the system, from the system towards the intelligence, and from the intelligence towards the final stage. So towards the purpose, the final stage is a purpose, and this create one very important research question: what is the bridge? How does a conventional process actually become the intelligent process? No need of sensors. The first thing is process innovation. Process innovation is the bridge. Traditional process versus intelligent process is highlighted. The flowchart is given in the slide 9. The traditional process, the left side, the operator, manual inspection, paper records, reactive maintenance, machine fails, production stops, everybody runs. Am I correct? Production call maintenance. Maintenance ask operator what happened, and then operator says, sir, actually it's not my fault, and for the last 3 days some small sound was coming, so the boss was operator knows this, he hear the sound. So maintenance ask, why didn't you tell us? Operators say, sir, machine was running. So operator need the production, there has a schedule. Okay, this is not a joke only. Many industrial professionals watching this know exactly what I am talking about. So intelligent process. Now imagine another process, smart machine. So intelligent process in the right side, it's a smart machine. It has a sensor. Is any tool breakage or before the tool break, any tool wear, the sensor will identify. They will identify the tool life, and they will give the alarm, change the tool. Connected data, am I correct? That's a digital twin. That's a actual standard will be there. So it's a process innovated standard data. From that data, it will create a algorithm standard. So from that, it will run. The both thing is run. Any variation in this will be highlighted in the dashboard. Sounds interesting, huh? AI predictions. So then the adaptive decision, then the continuous learning. Now ask yourself, what actually changed? Did the machine change suddenly? Attend an AI course. So did someone install one magical software and intelligence appears? No. So the process evolved. We change how we observe, how we sense, how we record, how you connect, how we interpret, and how we predict, how we decide, and how we learn. So the machine didn't suddenly become intelligent. The process evolved, and that is exactly the key message of this slide 9. So you understand this. Remember this in this line. AI is not a magic added to the machine. Intelligence emerges when the process learns to observe, connect, predict, adapt. Sir, use that standalone shot. It's strong, express your philosophy while remaining more academically. It strongly express your philosophy while remaining more academically defensible than absolute claim. We move on to the next slide. The intelligent ladder. How a conventional machine become intelligent. Now I want you to introduce another thinking tool. I call this as intelligent ladder. Imagine one conventional machine. Let us climb step by step. Level 1, mechanical machine perform work. It rotates, it cuts, it pumps, it moves and compresses and it transports and it is useful. Yes, it is useful. It is intelligent, not necessary. So the level 2 is automate. Now we add the control logic, then the microcontroller sequence program. The machine follows the instruction. It is more capable. Yes, but remember, following logic is not actually, it is not automatically same as the learning. Then the level 6 is connected. So now the machine communicates, data moves, and machine to the dashboard, and machine to the server, and machine to the edge device, and machine to the another machine, and connectivity creates. So each and every process has a connectivity. So next level is the observable one. Now conditions become visible. The temperature trends is visible, the vibration trend is visible, the current trend is visible, and the cycle time is visible, and the quality condition is visible, and the energy consumption is visible. The machine is no longer silent. We can observe it in a state. Then next we move on to the level 5. It's a predictive one. Now the system begin asking what is likely to be happen next. Failure or quality drift or tool wear. Once the system identify the tool wear, it will give the alarm to the dashboard to change the tool. And if there is an energy spike is there, so that we can understand there is a load is overloaded in the machine. So we need to find the root cause, and then the possible root cause is displayed in the dashboard and we can easily identify. And the process instability, we move from the what happened towards and what happened, and then next level goes to adaptive. This is the 6th level. Now the system changes respond, the speed adjusted, feed modified, and then the cooling changed and the path corrected, the maintenance action prioritized, and predictive maintenance is done. And then the system doesn't only observe, it responds to change the condition. So the next level is level 7. It is a learning stage. Now the system improves from the experience and it overcomes the influence, the future behavior and pattern become the model, and the model are updated, and decision improves. This is the journey towards the AI. Your 7-level ladder process exactly from the mechanic to the automated and connected and observable and predictive and adaptive and finally learning. Now I want to challenge you, every engineering college watching this, at which level is the laboratory? Level 1 mechanical, level 2 automated, level 3 connected, level 4 observable, level 5 is predictable, level 6 is adaptive, level 7 is learning. And here is most uncomfortable question, and which level is your curriculum? Are students only operating equipments? Are they learning how intelligence emerge across the complete system? This can become another standalone. Look into the lights, slide 11. From the rupee value, the hardware to intelligence. Assert, sir. This is a major viral. Now we come to the example. I promised you one motor, one ordinary. It's very ordinary, am I correct? You can find motors everywhere, the factories, in the pump, in the conveyor, in the fan, in the compressor, in the CNC machine, in the robots, in the AGV, in HVAC, and or also in the agricultural industries. Now, I want you to ask, can this ordinary motor become intelligent? Let us see. Stage 1. Motor runs stage 1. Power supply. Motor rotates and spinning clockwise or anti-clockwise. It's useful, yes. Intelligent? No. It simply performs the work, but in the stage 2, the speed is controlled. So we control the speed, VFD, PWM, servo drive, and closed loop control. Now the motor is more controllable. But is control intelligence? Not automatically. So sensor need to be added. The stage 3. Now we add sensor. On screen current is visible. Then our dashboard is showing the current value, temperature value, vibration value, RPM. Something important has happened. Physical reality is becoming measurable. The motor is beginning to gain a digital voice. The stage 4. In the stage 4, there is a IoT connectivity. So connect the data, the edge device, the gateway, and industrial network. The cloud performs, the local server. Now the motor is not isolated. Its condition can be traveled. So that dashboard is monitoring. This is the stage 5. The dashboard has a current trend, temperature trend, vibration trend, or a speed trend. Now we ask, what is happening? Is temperature is rising? There is the defect, or vibration is changing, or current is increasing, or RPM is unstable. Visibility has emerged. So failure predictions, the stage 6, it is very important. Now historical data means the pattern. So we begin with estimating the bearing degradations and overload, thermal risk. So every life has been already calculated and it is registered in the data. So any misalignment is there, any data failure probability is there. Now we are no longer asking only what happened. We ask what may happen next. This is the recommendation action. This is the stage level 7, and then AI doesn't merely display, it recommends. It reduces the load, it inspects the bearing, and it schedules the maintenance, and it changes operation window and indicates the vibration of abnormal like that. So decision support has emerged. So system adapts. In the stage 8, the system will automatically adapt. Now imagine the system changing the operating condition, speed adjusted, load redistributed, and cooling increased, and maintenance prioritized, and process schedule modified. Now I want you to answer, where exactly did intelligence begin? At the stage 1, the motor runs, or no? At the stage 2, speed controlled, maybe controlled but not necessarily intelligent, am I correct? In stage 3, sensor stage, we gained visibility. In the stage 4, we have the connectivity, we gained communication. But in the stage 5, because of the dashboard, we gain the observation. So stage 6, we have the prediction. So now intelligence appears very stronger. In the stage 7, there is a recommendation, there is a decision support system, At the stage 8, there is an adaptive system, even more advanced. So, where exactly did the intelligence begin? My proposition is perhaps intelligence didn't begin with the magical point. Perhaps it's emerged progressively as the process improved, process evolved. So, therefore, with the process innovation, your exact motor case study progress through all the 8 stages and ends with the same key question and answer. So motor case study is very important. Think about it. What just happened? We started with the motor and then control, then sensing, then connectivity, then visibility, then prediction, then recommendation, then adaptation. Same physical motor, but maybe the same process. No, the process evolved, and as the process evolved, the capability evolved. As the capability evolved, data gained context. As the data gained the context, the predictive becomes possible. As the prediction improved, decision support emerged. As the decision and adaptive improves, the system moved towards the top class intelligence. When there is an intelligence, that is why I say AI is not the first step. Intelligence is the result of engineering journey. That line anticipate your final AI PI framework, where the journey ends in the intelligence. After the process understands and the innovation, then the automation, and then sensing, connectivity, data, prediction, decision, adaptation, and learning. Now we have a transform on motor from the hardware towards the intelligent asset, but one motor is not a factory. One sensor is not a smart factory, not a smart manufacturing. One dashboard is not a industry 4. One AI model is not an intelligent ecosystem. So what happened? When we connect machine to machine, robots and CNC systems together, the sensors together, the edge device, industrial network, contextual data, AI, and human decisions, and adaptive actions. Then we enter the intelligent factory. In the next, I will break down the complete smart manufacturing technology stacks and connect it with the intelligent robots, industrial IoTs and industrial digital twins, predictive maintenance, and AI-driven manufacturing systems. This is where the isolated technologies begins and becomes an intelligent architecture. So, mentor delivery notes for this block, sir, and 3 strongest thing is there. AI maybe identify the pattern. Engineers must understand the physical meaning of the pattern. The second one is AI, which level is your laboratory and which level is your curriculum. And the third is perhaps intelligence didn't begin with one magical point. Perhaps it emerged progressively as the process evolved.